1, 2, 3 test.
So you still
Hello. Hi, Michael.
Hi. Let me know what I.
Yes, come again.
It really shouldn't be a problem for the low power working group to have chairs with no power, right?
It isn't indeed. We have redundancy.
I was wondering because the room did not open in advance. It opened just at 10.
Yes, same here. I was getting nervous.
So, okay, I just assumed it was because the chair hadn't joined yet. But
well, the chair were trying to. They were denied.
Sorry to interject. So this is Lorenzo from Miteco. So just to clarify that the room was started late because the Jabber server is not working. So we wanted to wait if it could start. So right now the Jabber room is not set up, but we wanted to start the sessions anyway. So apologies for the delay.
Okay.
Okay, thank you. So, Michael, you'll be on Jabber, right?
Yes, I will. I am in the Jabber room directly, although I think I have to reconnect now.
It'd be great if we could have 1 or 2 note takers, please. Anybody in the audience who's willing to do that?
I'll contribute.
Yes.
Thank you, Pascal. And somebody else said yeah, but I didn't recognize who it was. So just to say hi, and then I'm going to turn off the video. Salut Pascal. Okay. It's 10:04, so I think we're going to get started. Ines, do you want to talk to the chair slide? Or yep. If you can, give it a try. Did we just lose Ines? I think so. So let's get started anyway. How is the sound? Can you all hear me? You can write in the chat. Do the slides look okay? Do they show up okay?
I'm right in the chat right now.
I'm sorry, Carsten, what was that?
You just said you can write in the chat, and I replied, you cannot write in the chat right now. We don't have a chat at the moment.
Oh, really?
So it looks like that's what Lorenzo was saying. There was a problem with the Jabber IETF Jabber server. So it looks like the Jabber room is up. I'm there as well, but there's no connection to MeetEcho. I'm sure they'll let us know when that can be tied together.
But indeed, if I'm trying to type in the chat, nothing shows up. So we don't have a chat.
There's no connection from the MeetEcho to the Jabber room, and so you can't even go. You can't use it. It's not like it's not bridged. It just doesn't work because it's the MeetEcho. The Jabber is the bridge between people.
Yep.
Okay. That's becoming interesting.
If you have a Jabber client, you can connect to the room directly, not through MeetEcho, and it works fine.
Yes, I think that's time to admit that I've never used Jabber and I don't want to try that right now. Well, I guess we can just do with audio. We don't need a chat, do we? And those who are in the Jabber room, you can relay the questions at the mic.
Well, yes. So, sorry, just one interruption real quick. If you reload your window, just reload the window. I just did that on my MeetEcho window. And now I can see the Jabber posts. I posted on my Jabber and it showed up in the room. And I see that Michael also posted, I think, on the Jabber room, and I see him on the MeetEcho screen. All at once, exactly. Let's count to 3 and we can all go.
Excellent, thanks a lot. That works. Do we have Ines on board? No, she's gone. Okay, probably run out of batteries. Good morning, good afternoon, good night, ladies and gentlemen, wherever you are. Oh, sharing the screen because I reloaded. Sorry about that. Okay, so this is a roll meeting. We have Pascal taking notes in CodeMD. We have Michael on Jabber. This is a note well. Whatever you are saying in this meeting falls under the policy of IETF. You should, I'm not going to read all of that, but you should read and have understood all of that to participate in any kind of IETF meeting. Okay, CodeMD, the link is here, but you have a button in the MeetEcho window. Slides can be downloaded from the link, but as well from the material button in the MeetEcho window. And we do have minute takers and JavaScripts. Something about a TV shown in a dome or something. I don't know whom this is addressed to. This is our agenda, working group status from the chairs, and we have Pascal running the show for 3 successive presentations, and Rahul for his root hack draft. And then we have Michael presenting the status of the ideas for 6550 BIS to update REPL, trim it from the features that have not been used so far, and ideas for improvement that we want to put together as an update to 6550. And a few minutes for open floor so that you can bring up any other discussion. Okay, regarding the milestones, those that we have achieved so far, turn on RST8538 has been submitted to ASG. Unaware leaves been submitted. AODV REPL has been submitted, although it's not moving forward that much. The authors are a bit distracted right now to react to the changes requested. Use of REPL info submitted, efficient in PDAO submitted. Upcoming milestones, reading from the bottom to the top, which is the order of time. The NSA extension draft, and it's in my turn to act on it. I still have to complete the shuffled write-up and submit it after that. We have this modifications, and that goes with 2 other drafts that are a bit late. We are waiting to get more resources to work on that again. Enrollment priority to be worked on. DAO projection going to be discussed today, and MOPEX and CAP also forward of us. Oops. So probably this shows the same thing again. Yellow is the hot ones, the ones we are working on right now, that are hot in our work to do. The green are those who are steady progressing, moving forward, but kind of behind the yellow ones. And blue is frozen. We don't know what's going on, or it's standby consciously. And REPL observation, yes, work in progress as well. We have 2 drafts that have expired. Maple Yang Beer CCast, and this was actually mostly driven by Peter van der Stock, so right now they're not moving. And we have 2 related drafts that are not working group drafts yet. One by Rahul that's being discussed today, and one by Pascal that we will act on as we get more bandwidth. These are the open tickets. I don't want to spend time going through each of them, but just to let you know that we're using the issues in GitHub as tickets. And yep, here we go. And these are the tickets that are open in Tracker for the world working group, somewhat overlapping the other ones. And with that, I'll turn, unless we have questions for the working group on that. Any questions? In chat or in audio?
Okay, I guess you're giving me the end. That's what I understand, Dominique?
Hearing nothing, reading nothing in the chat, I'm assuming it's your turn to present.
Okay, so as we said, I have three drafts to present, but two of them don't need so much time. The one that really needs discussion is the DAO projection. So that's kind of cool that we start with this one, and if we take too much time, then we'll just steal from the other two because they don't need that much. Next slide, please. So this is about the DAO projection, and as you know, this is a new operation in REPL that makes it capable of SDN type of operation with a controller that will lay out what we call tracks, which are possibly complex paths between an ingress and an egress node. You may see that as a tunnel, but since it can be multipath, it's a bit more complex possibly than a tunnel. And if the packets have to go between the ingress and the egress, there is no need for tunneling really, because you just insert the RPI as you normally do within for REPL aware nodes inside this track. But if the packet is injected coming from the outside or going to the outside of the track, then there's normally a need for encapsulation, just like you would do in normal REPL for an external route. So what changed? A lot changed. We've been working very hard. I'm aware of at least one candidate implementation which is going through. I hope there's more, but we are not getting much feedback on the mailing list, and that's a bit sad. But if people are trying to implement, please give us feedback, because yes, we want to solve the problem, we want to work on it, but we need to understand what the problems are. The first thing that really came to mind is the fact that initially we decided to separate the topological information from the laying out of the track. And this draft was supposed to be only laying out the tracks. As it goes, there was never a draft which would give topology to the root or to the PC. So we kind of decided to keep that into this document. So we created this sibling option. And the recent changes enforce that the main DODAG in which we are building this PDAO route has to be operated in non-storing mode. For one thing, as Karsten usually tells us, it's the mode that is the most used. And for the other thing, the non-storing is the mode where the root already has topological information about the DODAG itself. So the only thing that needs to be added is the sibling. So that's why we provide this new sibling information option, and we say the DODAG has to be operated in non-storing mode. The other big change that happened recently is how to signal a track that is not simply a serial list of nodes, A to B to C to D, right? Now we can do more complex stuff, but installing something more complex with just one message was kind of hard. So what we did is we say one PDAO message installs one segment. And then if you want to build a track, then that's more complex. Then you install more than one segment and you correlate them all with a track ID. So that kind of makes it easy for the controller to handle the segments separately, or the controller or the root to handle the segments separately. And that can be decoupled from the activation or deactivation of the track. Like the controller may decide that this segment is not operating well. It might enable alternate segments and disable that segment in runtime. So you can change the structure of the track in runtime by changing some of its segments without necessarily disabling the whole track. There's also a little change of structure that happens is, to simplify again, we say in one PDAO message, there can only be one list of hops. So whether it's a VIO, so it's storing mode, or SRVIO, which is non-storing mode, source routing, either way, there is only one list. That's what we call the route projection option, so a VIO or an SRVIO. And but still there can be multiple targets. So if you think again as a segment or a track as a tunnel, then the tunnel may lead just to the tunnel egress. Obviously, it leads there. But it could also lead to neighbors of the tunnel egress. And those neighbors can be signaled as targets. So basically, the PDAO tells you those targets are reachable over this tunnel. Now, as signaled today, the tunnel is between the requester and the egress. And we'll see in the question that maybe we can do better than that, that we can ask for a tunnel between NEA and NEB, and we could also ask for a tunnel to be bidirectional. So that's part of the pending questions we'll see in the end. So right now, basically, the main change that I'm talking about is we can signal a track. The track can be made of multiple segments. They're all correlated with a track ID. And we need to figure out exactly in more details how we do the encapsulation and when we do the encapsulation, how we do it, and what exactly gets signaled in the via option. For instance, do we signal the ingress? Do we signal the egress? Or can we elide them? So that's part of the things which could be improved and tuned in this document. Next slide, please. So as I said, we now include the topological awareness. We signal the structures through non-storing DAOs, normal of the main DODAG. We signal the siblings through the sibling information option. What we do not do is select which siblings would be advertised. I mean, if you're in a very dense network, you may not want to advertise every sibling, every node that you can see. Maybe there's 100 of them. And so the problem of selecting sibling may depend on the use case, and it may be quite complex. So it's out of scope, but certainly for a given implementation, there will be a given deployment, there will be a need for some logic, some intelligence to select the siblings that are advertised to the root, knowing that what the root knows in terms of sibling is what it can use to build path. And if you don't advertise a sibling to the root, then the root will not know that it can use it in a path. Next slide. So as I said, there can be 0 or multiple ripple target options, and they really mean the siblings which are reachable over this track. There can only be one VIO or SR VIO. That's for simplification. So there's only one ACK to be sent by the ingress of the track. Now, the VIO is sent to the egress. That was always the case. The SR VIO is sent to the ingress. In the case of a VIO, the message is propagating along the reverse path to the ingress, and the ingress anyway sends the ACK, as I said. The track ID has to be a local instance ID. For now, it's a local instance ID of the egress. So the track is really a form of DODAG that's rooted at the egress. So we take we identify the track by a local instance of that egress, and the fully qualified instance ID is the IP address of the egress plus the local instance ID in the namespace of that egress. Now, if we want to consider bidirectional tracks, and like I said, it's a question that we have in the end, then it could be of the ingress or of the egress, depending on the direction of the packets. They might go along the DODAG, or they might go along the reverse DODAG. Next slide. So there was a little bit of change in the structure of the PDAO option. So this is, well, the VIO or the SR VIO, actually. So the big change is we mandated 8138 compression to make sure that it's always compressed. Initially, we could say it's compressed or it's not compressed, and we'd express whether it's compressed or not. And since the SRH6LoRH is self-descriptive in its compression, and one of the compression mode is actually non-compression, it looked easier to just always use the SRH6LoRH header and then the list of the address compressed as the SRH6 lower H would indicate. So now there is an SRH6 lower H header in the PDAO. Normally, if you're using storing mode, you need to have a strict sequence of address, because each next address must be a neighbor of this address, so you can always forward, and you don't have a risk of a loop. Loop avoidance was a delicate thing that also needs to be considered when you look at this draft, and if you make a review, think about loop avoidance. What we did to avoid loops is we enforced that the storing mode is always strict. For non-storing mode, we allowed non-strict, but then there needs to be another kind of non-storing mode path between the loose hops. So with this, we can allow track within tracks, if you like. So the loose track would be within a non-loose track, something like that. And you'll see why when we discuss encapsulation, but it's that again is not an easy discussion. So that's why I wanted time in this working group to kind of explain the primes, and you know, on the mailing list or during the discussion, get feedback on how to do things. So this SRH6 lower H provides you the compressed list of the VIA addresses. That's a strict in storing mode, that's loose, if you like, in non-storing mode. In non-storing mode, if RFC 8138 is effectively deployed in the network, then the specification adds that we want the optimized format to be used by the root, which basically makes it so that what you find in this option is exactly what you would put in the packet. So the encapsulating node never has to compute the compressed form of the SRH6 lower H. As you know, in normal REPL, the only node which computes an SRH6 lower H is the root. That's because the RH always goes from the root. So the complexity of computing the compressed form of an SRH6 lower H is only in the root. And we want to conserve that feature because it's a complex code and we don't want it distributed in the nodes. So the whole idea is we use the SRH6 lower H format here so that the root basically provides the pre-encoded header to be inserted in the packet when you do the encapsulation. Now think again when you hear this of should we signal the ingress in this list and should we signal the egress in this list? Because if we signal the ingress, then all of a sudden you may say, hey, then the ingress must consume the first address when he actually forwards the packet because that's him. If you don't provide the ingress in this list, then how does the ingress know which of its address it should use? That's an important question because the compression depends always on the previous address. When you send a packet, the sender is the compression reference. So if a node encapsulates and adds a header like this, the source address that it's going to use is the reference for the compression. So it must be very clear which address is used to ensure that we get the compression we expect. So this is kind of the primes we have, and we need to think through as we progress this document. Do we signal the ingress address, in which case the ingress node needs to consume it? Or do we not signal it? And then how do we select it exactly? Next slide. Oh, another thing is, as I said, we want the SRH6 lower H fully compressed by the root if RFC 8138 is in use in the network. Well, if you want it fully compressed, it might be that you have different compression, like 2 bytes and then 4 bytes. And with RFC 8138, you need to insert more than one SRH6 lower H in that case, because each SRH6 lower H is for a fixed size. So if you go from 2 bytes to 4 bytes, then you need to switch SRH6 lower H. In that case, the root will have to place more than one in this option. So basically, from the first SRH6 lower H header down to the path at the end of the option, there would be a sequence of SRH6 lower H, actually, not just one. That's only when RFC 8138 is in operation in the network. Okay, next slide this time, please. So for now, there is text which says that you encapsulate if you are not in the case where the source is the ingress and the destination is the egress. Now it's what the text says. It's not fully exact, and we need to reword that a little bit. First, there are two cases to keep in mind. The first case is I want to complement a non-storing mode DODAG with storing mode PDAOs along the path with the goal to compress the source route header. So in this case, the mode of operation is non-storing. Well, we say it has to be in the main DODAG. The PDAO is storing, and the RPI is always the one of the main DODAG. So if you look at it, when what the root builds is a loose source routing, and between two hops of the loose source routing, we use the PDAO storing mode to go between the loose hops in the source routing header. Which means that the RPI is correct. You don't need to encapsulate between the loose hops because the RPI is still indicating the instance ID of the main DODAG. So actually, if the path is non-store if the PDAO is storing mode and the RPI that comes in is already correct, actually you don't want to encapsulate. You just want to forward along the storing mode PDAO between the loose source route hops. So this shows you why actually this text which says you have to encapsulate if the source is not the ingress or the destination is not the egress is not fully correct. Same thing when you forward along segments of a track. Actually, the RPI contains normally the track ID. So even for a given segment, you don't need to re-encapsulate. You don't want to re-encapsulate. You want the track ID to be seen as you forward along the segments of the track. So we probably need some clarification on exactly when you need to encapsulate and why you need to encapsulate. The other thing that I will have slides next is when you use a source routing header, so it's non-storing PDAO, normally to insert it, you need to encapsulate. So each time you forward a packet along a segment, you would need to encapsulate to place the routing header for that segment. Now, if you do that, then the destination becomes the endpoint of the segment, not the track endpoint. So when you look at the packet, it does not signal the track anymore, it signals the segment. So this is completely acceptable. The draft allows to put a track in another track. So if one segment is considered as a track, for instance, with a strict source route, and the track itself, the main track, is a loose source route that goes across the segments, then that fits the model, that fits the architecture of this document. But when you look at a package, you don't see the track, the main track, you just see the segments on the outer header, which might not be what you want. There is another mode whereby we kind of refill the routing headers segment by segment. But if you refill the routing header, it looks a lot like routing header insertion. It's not, but it's something that we have to debate because it basically looks acceptable if you look at the opposition against the routing header insertion, but it's still not fully clean because it's, well, I will show you in picture because it's kind of complex. But basically, the thing I would like to achieve here is when you forward a packet along the segments of a track, even if the segments themselves are source routed, you don't effectively encapsulate. You change the source, you change the routing header, destination stays the track egress. The RPI stays taken from the namespace of the track egress, so the external header always signals the main track, not the segment. I will show you that in drawings. Next slide. Okay, so this is basically the main discussion I wanted to have and those drawings that I promised. So initially, the simplest case, and this works in storing mode and non-storing mode PDAO, is you have a track ingress, you have a number of hops, you have the track egress, and the PDAO in this case is shown in non-storing mode, in storing mode, I'm sorry. So the PDAO is sent by the route to the track egress, then it's forwarded along the reverse path to the track ingress, and the track ingress sends the acknowledgement back to the route. If a packet comes from the outside, so outside source or outside destination, the idea is normally you should encapsulate to place in the packet into a header where the destination, the final destination, is the track egress, and the RPI is this track ID. Okay, so that's classical REPL when you have a local instance, and you have a bit in the RPI which says the namespace is taken from source or destination. In this case, would be set to destination, and the track ID is the local REPL instance ID. Kind of simple, right? It's what we do for REPL and nowhere leaf. A packet coming from the outside has to be encapsulated to place the RPI in the packet. And it's not just the RPI, but also to set the destination of the packet, because the instance is local to the destination. So to be fully signaled, you need both the destination to be the track egress and the RPI to be the track ID. So I hope you find this is the simple case, because now the complex case come in. Next slide, please. Okay, now I want to do 2 consecutive segments. And I'm in non-storing mode. There are 2 ways of doing this. So basically, the track itself, the end-to-end track, would have a loose hop 1, then loose hop 2, then loose hop 3, meaning that there are hops in the middle, but the routing header that is shown for the track packet and the encapsulation that is done at the ingress of the track says routing header loose LH1, LH2, LH3. So that's the quote-unquote inner track. Now, because you have to go across the loose path between LH1 and LH2, and that loose path is, if that loose path is non-storing, in which case my arrow with the PDAO is kind of inexact because it's really populated in the LH1. But if you have to do that, then basically you would need to re-encapsulate the packet at LH1 with the source route header that goes the hops between LH1 and LH2, and the destination being LH2, and a track ID which is taken from the namespace of LH2. So the main track is now placed into track 1, which is the first segment. And then LH2 decapsulates, or it could be the egress, which could be the node just before LH2. In this case, what's illustrated is the egress is the node just before LH2. So the node just before LH2, the neighbor of LH2, decapsulates the packet. It's the track egress. Finds that the next entry in the loose source routing header is LH2. It's one of my neighbors. Fine, I pass him the packet. So it's not compressed at this time. It just contains the inner track. Loose hop 2 finds that it needs to go to loose hop 3. It has a non-storing path to there, so it redoes an encapsulation to an egress, which is loop hop 3 or one of its neighbors, and blah again. But as the packet flies between the loose hops, what you see in the outer header is an encapsulation that goes between the loose hops. So you don't recognize the track, which is actually hidden inside the encapsulation. Now, what the draft allows to do, and that's the big discussion, is to say, hey, when I am the last hop of a track, and I have basically another segment which starts at me towards the destination, then I can kind of remove the outer header and place a new one which has the same destination, which is the final destination. Same RPI, because it's the track, but just change the source and the sequence of hops. So I become the source. That's why it's not a header insertion. I become the source. I add the list of hops between me as loose hop 2, say, and loose hop 3. And I keep the final destination as being the end of the track. If you do this quote-unquote header insertion, the last entry in the outer header, the final destination, is always the same. It's the final destination of the track. The RPI is always the same. It's the track ID. So if you do this kind of weird quote-unquote header insertion, then you don't have to encapsulate a track within another track. You just kind of reload the routing header as you do from the source route between loose hops. You just reload the routing header to indicate the strict hops between the loose hops. Now that allows to keep signaling the main track if you have to do quotes or anything based on the track ID. So whether we want to do that, whether we can do that, for the six-man perspective, that's the discussion. But the good thing, if we were doing this kind of routing header reload, is that we could keep signaling the track ID in the outer header. So, and with RFC8138, it's very easy to do, by the way. Okay, next slide. Now we are looking at the same picture in storing mode. So this time the PDAO arrows are correct. They are sent, from the segment egress to the segment ingress. And you see this node I call relay in the middle. So say the track is indicated by the final destination and again local Ripple instance ID from the final destination as track ID in the RPI. If you take the position of the relay will receive a packet which final destination is the final destination and for which it has a segment, a track. It already has the right RPI in it. So it doesn't need to re-encapsulate. We are pretty much in the same case as the one I made at the very beginning of this discussion when we use non-storing main DODAG and we use projected DAOs in storing mode to kind of shorten the routing header. We are in the same situation. Yeah.
I see we have Alvaro in the queue. Alvaro, do you have questions?
Okay, I'm sorry. I was not looking at the queue. Yes, Alvaro, please.
Sure, hey, no problem. So in slide 8, if I understood you correctly, you said that the intent is if you are the last segment or the last hop or something in the segment.
Yes, last hop is the segment, yeah.
Then you're saying you can remove the header. So I don't know if you have talked about this at Six-Man. I know many of you follow Six-Man.
I do follow Six-Man. I've followed all the SRv6 discussions about header insertion. And Michael and we are very, very familiar with these discussions.
Okay, good. That's what I was going to mention, that it would be very good if you look at everything that happened there so we don't repeat it again.
If we want this thing, because if Roll says we don't want this thing, we're happy with the re-encapsulation for each segment, then I don't even bother with Six-Man. Now, if the group finds that avoiding the re-encapsulation and doing this form of header insertion, which is not the one that Six-Man did not like, it's kind of different. then we can go and fight at 6-man or decide what we do. The main difference with this and 6-man is, okay, I need to, maybe I should have had the picture, but figure that between loose hop 1 and loose hop 2, you have a sequence of nodes.
Yeah.
But the routing header would basically say this sequence of node, and the last entry in the routing header would be the destination, the final destination of the track, because we always want to signal the track by being the final destination as the namespace, and the RPI being a local REPL instance ID in that namespace. So we need the final destination. That is the final destination, the guy on the right, on the right on this picture, the dest. Now, when LH2, and at this point for this drawing, LH2 would need to be the egress of track 1. So not a neighbor, strictly the egress. LH2 gets the packet, and all the routing header has been consumed, but him, right? I mean, he gets the packet, so it's consuming it. And next header is the dest, final dest. So now it's loose between me, being LH2, and dest. And the operation will be, okay, I remove this routing, this encapsulation altogether as if I was the final destination, but I'm not, because there is dest on my right. But I remove this routing, this encapsulation, and I do a new encapsulation where I, LH2, I'm source. And now there is this new list of routing header entries, and the last is again destination. So we remove a header and we add a new one instead. It's just that we were not the final destination of that routing header. We were the penultimate hop. But we still take the liberty of removing the outer encapsulation, placing a new outer encapsulation with the same destination, ultimate node, but now LH2 as source, and then this number of routing headers. So that's why it's not the header insertion, because now the source has changed. The source of the encapsulation becomes LH2. So all those discussions at 6-man saying, hey, you cannot track who did this, right? When there is a header insertion, it's anonymous. You don't know who did it. You cannot send the packet back to that originator if there is a prime. That's not true. We change the source. We know who did it.
Right. So the discussion 6-man with Spring was more about removal of the header. That's why I was asking about if you were the next to last hop or if you're modifying the header somewhere else. In any case, the important thing here is go check some of the discussion and some of the resolution to that, which has a lot to do with how you can or not interpret 8200. But in any case, you said the important thing is let's first figure out if we really want this or not.
Yeah, exactly.
Thanks.
So the draft still has the capability to do what's written there, which is kind of the default, if you like. The egress of the intermediate segment is the next loose hop or the node just before that, decapsulates, re-encapsulates. If you do that, then the outer header signals the segment, not the track. So basically a track within a track. If we want to avoid that, then we would need to do this previous last routing header hop re-encapsulation game that I was discussing. Next slide, please, because I don't have much more time. So what I was saying here is the main thing is the relay doesn't need to change the RPI. The RPI is the one of the main track, so it doesn't need to encapsulate. It's just forwarding. You just have a routing table which was populated by PDAO2, whereas along the segment 1, it was populated by PDAO1. But the routing entries from track ingress to track egress, they look the same. It's just not the same PDAO that has signaled them. So there is no decapsulation, re-encapsulation, and there's still the question of could there be a loop somewhere? It's really the control of the root, make sure that the root did not do crazy things, but it could be loops if it ties the segments the wrong way. Next slide. Yeah, and that was actually the slide where we should have discussed this this thing with Alvaro. Compared to 2 slides ago where we did the non-storing mode with track in track, now that's where I discussed this SRH reload operation where you truly bump a new source, and which is the relay, and a new sequence of routing headers with the same final destination, which is the track egress. Next slide. Now we had a number of discussion points on the mailing list. The first one is the lifetime unit. So right now we're saying REPL has a lifetime and a lifetime unit in the configuration option. And so everything is kind of timed with this lifetime unit, so we can express the lifetime in a more concise way, because you kind of multiply it by the lifetime unit. And Women, as an implementer, says, maybe for the projected path, we want a different kind of unit. Could you signal it in the PDR request? And I guess that can be done. We probably would need to change the PDAO format as well, because we probably would also want, so the PDAO right now is the same format as DAO, but do we want to express a lifetime in there that would be different form? That's the first question. I have nothing against it. I would like to see a discussion on the mailing list. Second question is, since the track ID is really a REPL instance ID, how do we differentiate when we receive a packet from something which is along a PDAO versus something which is along a local REPL instance? And I don't see that it should make a difference. But if there is a good argument that, because it's the same thing, kind of, but if there is a good argument that it should make a difference, then maybe we would need something in the RPI to signal that it's a projected path. There is 1 bit left in the RPI, so we could, if we wanted to. But then again, we'd like to see the mailing list react to this. Main problem, the main thing that could lead to big changes in document is Women is asking us if we could make the track or a segment bidirectional. And this impacts a lot of things. In particular, the fact that we signal the track ID with the destination of the packet. If we make it bidirectional, it could be either the source or the destination of the packet. Same DODAG, basically, if you want, but recognized by either the source or destination. REPL allows that. So for the packet forwarding, we would know, because there is this bit in the RPI which says the namespace is taken from the source or the destination of the packet for local REPL instance. It's more things like this header change that I said we just discussed with Alvaro. If we do that kind of change, you saw that the source of the packet changes. Now, if the source of the packet is describing the track, we cannot do that change anymore. So that's why I said, first let's agree on what we want, and then we'll go to Sigman to get it if we can. But for instance, if we want to signal a packet going forward or backward along a track, then the track could be signaled by the source or the destination. If we are taking that path, that changes typically this aspect of being able to stitch, to reload routing headers. And then suggestion to add a flow. Yeah, we can add flows, certainly, to make things clearer. A clear thing is the PDAO and PDAO which are generated because there is a PDR, PDAO request message. They don't live on the same time. That was clearly expressed thanks to discussions we had. The route is free within, for a given PDR, which is a contract to build a track. It's free to change the segments, use lifetimes for the segments which are not the same as the lifetime that is guaranteed for the PDR. It's completely decoupled. Next slide. So need help. Loop avoidance needs to be think through. There was also this request. They had the PDR, for now it's always the source of the ingress of the track. Could we send a PDR for which we are the destination, or could we send a PDR for which we are neither the source or the destination? in which case we would need to be able to signal both in the PDR, which we can't today. How do we maintain the availability of the siblings? So some words about using RFC 8545 or something, or REPL says you can use ND to monitor your neighbors, kind of that's missing for siblings. And as I said earlier, do we want the ingress and the egress to be listed in the RPOs? Is the egress an implicit destination of the track? There's no text about that, but we want to be very, very specific if the ingress and the egress are listed. Right now, the text says they are. Like I said, if you want to build the full RPO so that the encapsulator can use it as is, and the ingress is in there, you would have to consume it before you actually sends the packet. And that's pretty much it. I hope you see that there's still a lot of work to be done. There's still a number of complexities. And I would like to ask the chairs to do something about, maybe forming a team or something to complete this document, because I'm reaching the limits of what you can do by yourself or with very limited feedback. So I would appreciate to have a stronger team to complete this document. And that's it for me. Any question? Michael?
Well, I guess this changes to PDAO is that I guess I didn't quite realize they were happening. So I think there's probably a lot of quiet because I think that we're sort of trying to absorb all the changes. And I think we're going to need some little bit of, I think we're going to need another session with the diagrams. I'm kind of happy this is on YouTube. I'm going to have to review it again in slower to be able to do things. I suspect other people will have the same issue for this.
Yes, I could improve the slides, but I need more time. Maybe we can have an interim. That would be lovely. And I would build more slides and explain more what goes into the headers and things. Well, explain it well because
more homework for you. I'm trying to say that before we can catch up and ask you intelligent questions, I think we're going to have to do some more homework. I said I didn't quite realize this was happening to the document, but I think your slides are quite good. I just need to absorb it, probably walk it through slowly once I see it on YouTube again. And then, we do need to have an interim to discuss this. I agree.
It's, it might look overly complex, but if you think at it, we're adding a new form of REPL. We have AODV REPL, which is like reactive. We have traditional REPL, which is proactive. And now we have SDN REPL, which is controller. And you can expect that there is complexity in this document, just like there is complexity in REPL. Or what we want to simplify it to the maximum, but it's kind of normal that it's not easy. The other thing is, initially it was a serial path, like we were compressing the source route header of the main instance. Now we are pushing tracks in the network. And as we do this, we look at the 6-dish architecture, we look at row. And so we want to do something which is a lot more than a serial path. We want this track to be able to do replication, elimination, all the games. And that's why you have all these segments. In my drawing, you have two serial segments, but you could think of them as forming a geodag. And so, there's more complexity that meets the eye to get this SDN for REPL. But at the end of the path, you've got all the benefits of row and the 6-dish architecture that you can get, like the multipath, row. So. I guess that's it, your chairs, for this talk.
Okay. You've pretty much eaten up all the time that was allocated to you. So
yes, no surprise.
No pressure, but if you can go through the other ones
just keep through
in
the
an
other
expedite way. Yeah.
Let's just keep through. So an hour leaves. So Alvaro is with us. I can only, next slide please, I can only thank Alvaro. We've been through excruciating details in this document to clean it up. And Alvaro has been doing like not just one, but 2 or 3 reviews till we get things okay. And then the main discussion that's still there is the one that we share with user REPL info and with turn on RFC 8138, which is how do we exactly word the fact that we want to reuse the configuration bits for map 7, which is for any map extension. So we've been through that discussion as part of this draft, and then we actually decided that user REPL info would be the normative place where most of this takes place. There was restructuring, there was a change of what it updates. So now we clarify it updates RFC 6775, and it does not update NPDAO. NPDAO will be the place where the status 1 will be defined, but the change of a REPL status, which is used by NPDAO, will be in here. Next slide. Next slide, please. Oh, by the way, unaware leaf, but you mentioned it, is now pushed for IETF last call or something. And so it will go through the ASG. RFC 8138 turn on went through the ISG. Next slide, please. So through the ISG circle, we made like 9 updates. And the only thing which is kind of, I think it's clarified now, but I've not seen Benjamin removing his discuss, is this MOB 7 discussion. So for each of the 3 drafts, so that's this one, that's unaware leaf, and that's user REPL info, you must say what the flag becomes for MOB 7, because we say if the MOB field is set to all ones, then the definition of the flags does not apply, which means that you have to tell the implementation today what they do if they test MOP and MOP equals 7. For this particular spec, we said if 6LoWPAN HC is active on the link, then RFC 8138 will also be active on those links, and only if. Next slide. Oh, one is missing. Well, there was supposed to be a slide on with the status. I don't know where it's gone, but basically it shows that it's all green, but for Benjamin Kedek's review. So maybe I forgot to push it. I don't know. But Alvaro, if you have any news from Benjamin.
No, I think he's just waiting to see the actual document where we talk about MOP 7, which is, yes. So when that comes in, I think it's just going to clear. So we should be okay.
Okay. And that's it for me. And I'm pretty much in time, dear chairs. Any question on any of those 3?
Wonderful. That's so good.
So did you take the action point? Maybe that on the next interim we could discuss the projection.
Yes, Inet captures that in the chat, and I put it in notes. So we'll act on that, definitely.
Okay, many thanks. And then I will give the ball back.
I don't think I've seen Raoul among the participants. Do you know who's supposed to present? Raoul, are you there? Hidden under masquerading name? Nope. Well, then I haven't seen him since the beginning of the session, so I don't think he'll show up. I suggest we just go through the slides quickly, just to refresh everybody on what the topic is, and then okay, and then we can move on to the 6550 bits discussion. So the topic for this draft. The motivation for this draft, I understand, is to get the confirmation from a leaf node that the path has been established to the root, even in storing mode. In non-storing mode, the DAO goes all the way back to the root, and the DAO ACK originates at the root, so it's safe to assume that the root has established routing state for that leaf node when it sends a DAO ACK. Therefore, when it receives the DAO ACK, the node can assume that communication is established and can start sending application traffic. However, in storing mode, the DAO goes hop by hop across the chain to the root, and the RFC 6550 currently says that the DAO ACK is issued by the intermediate router back to the node and between intermediate routers, and so they happen in sequence as shown at the bottom right of the slide. And therefore, when the leaf node receives a DAO ACK, there's no guarantee that the path has been established all the way to a root within any amount of time, even following that. There could be many reasons why the path establishment will fail along the path up the root. And so Raoul's proposal is to add a message flying back from the root to the leaf node when state has been established at the root, meaning that the path is now fully established. And I think that's what it shows here. So you can see DAOs percolating up the structure and this root ACK message going back unicast to the leaf node from the root. And in order to request that final acknowledgement, Raoul's proposal is to add a flag in the transit information option that goes with the DAO, requesting for that flag. And the root seeing that flag would then generate the root ACK. Now, there's an aggregation that can take place on the way up to the root by intermediate routers. So we have to make sure how this is handled. And also we request the device only to send 1K. Why not hold the ACK? Okay. I'll answer. I think the slides answer that. Yeah, we already discussed that. Sorry, I'm trying to carry on through the presentation, and then we'll have the discussion. So there is an issue with this K-bit. We said that the leaf will only request once after a reboot for that root ACK, and not with the subsequent DAOs that it uses to refresh the route. Therefore, that's state that has to be remembered by the intermediate routers for each of these leaf nodes. Which I understand is pretty much the way the E flag is needs to be processed as well. But I may need help exactly on the details of that comparison. So that's a discussion about the K flag and how it's handled. And now the situation with Ripple unaware leaves. And so in this case, DAO with the K flag will be sent by the 6LR that acts on behalf of the rule. And this all path establishment will be between the rule sending its NS and the 6LR sending the NA. So the NA will only be sent back to the rule once the path has been established and verified through the root ACK by the 6LR, because the rule, not knowing the Ripple control messages, has no way of receiving a root ACK. That's the way we deal with rules. Okay, and the last version. Okay, I'm not sure which were the updates in the previous version, so pretty much that's all I can tell about the content of the draft. And then we can have the discussion. I see Alvaro asking about why not hold the DAO ACK, and there was a discussion. I guess Pascal or Michael, you you could remind us of the reasons. My mind is blank at this time. Michael, Pascal, anybody wants to come up to the rescue?
I can't where we clarified it. I know that my code implemented it the way Alvaro suggested, and it was suggested that it was wrong. And aggregation is part, I think, where it becomes obvious that it's wrong. I can't remember where we actually clarified that, because my brain's not working very well either, but we did at some point. So
Okay.
but that was and there was that was actually an interoperability issue. It would be. Anyway.
Yeah, I'm sure it's in the slides of one of the previous meetings, so I'll go through that and provide
And
a
capture
link
the
in the
minutes.
notes. Yep. Any
I don't know if
questions?
we have
Yes?
this. Sorry, Dominique. We have this question of taking notes for Ripple v2. I realized I created a second placeholder where there was already one, and I'm perfectly fine to merge them. But that's part of the things we could put in that placeholder, is to make sure we clarify the way the acknowledgements are sent, because it seems that the original Ripple could be misunderstood the way it was written.
Okay,
So
good.
as part of the update, we could be much more clear about the hack.
So where's the place you just mentioned that you captured the requirements for 5550 bits?
Pascal said placeholder, but I don't know which placeholder that was.
Oh, I'm sorry, I was muted again. Oh. Yeah, I have my own GitHub, and Ines has her own, so just realized there was a collision there, so we'll just merge them. It was all discussed in the mailing. Or maybe it was private. I thought it was the mailing list.
Okay, so we'll just merge them. So Michael, I think you're up to discuss 5550 bits.
Sure. Next slide. So I guess you guys created this placeholder for this. That's what maybe you're talking about. And we're supposed to dump content in it. This is a GitHub to either open issues, or I guess, Pascal, we're maybe even putting the beginnings of a draft in there as we go forward. And I guess that was the point. I didn't make this slide. Next slide. Well, I can't read that. I didn't write this slide. Anyway, that's the contents of it, of what we're putting in here. And the idea is that this is some of the points that are going into it. And so that's great. So we have these 7 points of the different pieces that could be into this part. And if you go to the next slide, I have some diagrams that I thought were ajustés à la largeur. The whole internet would make a bit more sense in French. We should do it that way. So this is what I was asked to add some stuff, and this is what I added to it. So there's a couple different concepts of what we could be doing. So the first concept is we could take RFC 6550. We can drop off that red stuff, the stuff we never used, such as the secure forms of the DAO and DIS and all this stuff. We never use secure forms yet because they don't work unless you do asymmetric crypto, which certainly 10 years ago when we wrote 6550 was considered way too expensive to do on constrained devices in that time. That's no longer as true as it was. And that's a consideration. We would add some clarifications. So basically the discussion would be which pieces we have good interoperability experience with, and what would we be doing is we'd be trying to build a 6550, which would now be at an internet standard. So that would actually require some evidence of interoperability and We don't actually haven't done a lot of interoperability, I think, as a working group. Maybe there are some associations and fora that would be able to provide us some reports about what is actually, which parts of the document have actually interoperated and which parts have never interoperated. And that would be a good thing to do do that kind of work anyway. So that's one thing we could do. That's not necessarily what we should do, but that's one thing we could do. Next slide, please. So the other thing we can do is we can do an RFC 6550 BIS. We can open up the document that we have, take the stuff that we used, throw it into this pot, take all these other documents that we're working on, and we'll have an RFC for soon. And we could massage all that text together so that we wind up with a new document that has everything that we've talked about so far into it. And we would essentially be, cycling at proposed standard. And we'd have a document that, well, it's probably going to be bigger, but hopefully, you know, we might cut some stuff out that's not that important anymore. And we would have a new document, and implementers could read a single document and would be, I hope, elated to only have to track one piece down. My guesstimate is that it's probably a 2 to 3 year effort to do that. And it's probably, in terms of the working group, elapsed time to work on it. And it probably requires something approaching a 1/3 FTE of somebody's time to, during a good part of that, to actually make it reasonably do a lot of editing, a lot of wrangling, a lot of going back and forth with different people and getting a lot of reviews. So I don't think it's something we should jump into without some view and to knowing that we really do have that resource out there who's going to take that editorialship onwards. So something to consider. I think it should be done at some point. Whether we want to start this in 2021 or not is an open question there. So next slide. So we could do something else, which is we could write a document that essentially provides a bit more of an overview. So it's of the documents that we are now producing. And I'm sorry if I forgot a document, a box on the right. There may be another document that I've misplaced in my brain. And it would simply say, you do that. This is how you do this. This is how this part fits together. This is how this part fits together. It would point back to 6550 for things. It would clarify parts of 6550. So this would essentially be a Uber update 6550. And it would pull in all the other Pieces that way. And so we'd have a document that would be basically the start here document for Ripple. But it wouldn't necessarily have to repeat much of 6550. It could repeat some of it if it wanted to, if it made sense editorially. But it would explain how the different pieces go together and what it means to have Ripple implementation that we would call quote V2. And part of the whole doing this is that I actually don't think that we're actually going to have anything that we call V2, but rather we're going to say, if you do this set of things and you implement this set of capabilities and you can discover certain things, then you have an implementation that can reasonably expand and do new things as we come along. We won't have to do the whole, obsoleting this or that or whatever. And this is something that would really be a MOP = 7 kind of event. And Carson says in the channel, it's a no-brainer. This is what you want to do. And of course, that's because engineers always present the best option last, right? And marketing people put the best option first that way. Discussion. Pascal, go ahead. That's the last slide.
Yes, obviously, that's very tempting. Now, there's kind of a merge of those two, which is do the internet standard based on 6550, 53, 54, and maybe 8138, which are the one for which we have lasting existence, and call that RIPL v1 internet standard, and then build the v2 profile, but not pointing on do this, don't do this, pointing on the internet standard for 6550 and then all the new stuff.
So we would roll a few of the documents over, cutting out the stuff we don't do, but not all of them. And it would be a relatively light editorial process of mostly removing content, and documenting for ourselves, at least, we usually, as to which parts have really interoperated where, and clarifying when there was a problem, what happened. That's what you're saying?
Yes, that's ABIS, really ABIS, which doesn't add. Yes, ABIS, which doesn't add stuff too much to, but remove some from the art of the RFCs, which are already RFCs in your picture. And
now, would that refer to use of RPL info?
Yeah, I think use of RPL info would be merged into it, because it's really about the existing. But unaware leaf would be out, for instance, I guess. Now that would be the discussion, but basically still provide a cleaned up version of 6550.
Well, I think as soon as you start saying that we're going to take some of those pieces in, then we get a little bit more into that melting pot kind of scenario.
Okay, so just 6550 base then, a real one, and then we talk about V2, which is what you draw here.
Yeah. I would have to be convinced that there was a strong interest from a wide variety of industrial players that run Ripple but don't seem to come to our meetings that often, that this was a valuable thing to them. Some people might feel, well, it should be really hard to implement Ripple so that people will buy my product instead. But I don't feel that way. So, I mean, given all the resources, I like what your plan. I'm just not sure that we would have anything left to do anything else at that point. I don't know. I
mean, it's not much harder to fix. I mean, just say you just fix 6550, removing the stuff you don't want and clarifying the things which are not clear. Just that piece alone is not humongous, and it's pretty much the same effort as writing the profile and saying do this and don't do that, just editing it in the original document. Looks to me
I agree with you. That part of it is very good, and having done that part, we would reuse it anyway for Ripple v2, right?
Yep.
Okay, so we would now have a document that would be much cleaner to be able to pull some of the other pieces into it. Now, Alvaro, could you clarify for me if could we write a document that does something and say doesn't change unaware leaves at all, but just changes its status because it's now interoperable 2 years later?
What do you mean changes the status?
Well, let's say we publish unaware leaves and use of RPL info. It's RFC blah blah blah, right? And 2 years later, there's no clarifications needed. And the Ripple V2 profile comes along and says, and it depends upon these other documents, which are currently at proposed standard, but now we've shown interoperability. Can we do a status change up to internet standard without revising the document?
We can try.
Or do we have to merge them all together? I'm saying, do we have to suck all those documents into one place? And
no, so I've never
changed.
Right. So I've never seen that done, because usually, there are some changes when we're going to internet standard, and we need to take some stuff out and all that stuff.
I thought that happened for IMAP or SMTP, or not SMTP, because that has a different
maybe
problem, but some other thing like that where they did a status change. on it.
So I've seen status changes done. I don't know if we can do a status change to internet standard, but we can try. I mean, the worst that can happen is we just recycle a new RFC number. That's it, right?
Yeah, that's true. We just change if there's no changes, it just, you're right. Yeah, that would be the.
So the one thing that concerns me about this is that you said that the stuff we never used was the security stuff.
Yep.
So what about security?
Well, the reason we never used it. The reason we never used it is because it wasn't well designed to begin with. It wasn't well explained, and there's a bunch of pieces that could never work, regardless of how fast, regardless of what magic crypto fairy dust you insert, right? But there's some stuff that was undesirable because in 2010 it was just too slow. You couldn't do asynchronous signing of DIOs fast enough and low powered enough to be useful. That might not be true anymore today, and we certainly see lots of cases where people ask about security in the routing protocol, which is solvable using the pieces that are there. So, like, I would rip out a bunch of stuff. I would absolutely rip out all the symmetric crypto authentication because it's meaningless, right? Anyone who can verify your announcement with a symmetric key can forge your stuff. So what's the point, right? But the asymmetric stuff, the working group just never really understood that it had to be asymmetric, and we're kind of being sold a bait and switch, I think. And so I think we're the IESG at the time. So what would we do with it? No one's implemented it. So that stuff can't go to internet standard because no one's implemented it. We don't have interoperability at all.
Right. So my point is that at some point, some security AD is going to ask, well, what about security? And for many of the routing protocols, we've sort of gotten away with, this is sort of a limited domain. It's inside this thing. If you can get into my network and look at my routing packets, I got other problems.
I got other problems.
Besides you, right, I have other problems. We have largely gotten away with that. Most
right. And all
people
and the whole role security threats document, right, explained all the different places where you can get in or where you need to be in or out or this or not. And we went on the applicability documents that did when I was chair. Partly was to deal with that, make everyone happy about that part. But you're absolutely right. I mean, Stephen Farrell was never happy with that result, right? And neither was I. Okay. But I mean, people haven't implemented it. So honestly, it can't go to internet standard. Of course, we don't have to obsolete the code points, right? We don't have to say that 6550, we don't have to rip it up and never let anyone read it again. Someone could come along and implement those things using the code points, find interoperability, and then, we have to do something in a document to advance that part to internet standard, but that would be a new document, right?
Right. So the whole point here is we just need to have a good security story. Either have a security solution that works, or have a really good story that's going to convince everyone of why we're fine without it.
It wasn't broken. We didn't fix it.
Can I?
Yeah.
We've been through security sections of many documents for role since, right? And we have kind of written the same words about layer 2 security, but it's not really. The one thing I have in mind is that there is a lot of work which is actually be done to secure the router-to-router posture evaluation, and I'm thinking about RATs, and I'm thinking about Anima, and those things are not dependent on exactly which routing protocol you're using. They just prove that you're talking to this guy with this identity, and that this guy is not compromised, and blah, and that establishes a degree of trust that you've got the right person with the right software in it. And if you want this kind of security, then you can deploy RATs, you can deploy Anima, and then run REPL over it. It's just that trying to put that degree of security into REPL binds things together in a way that I would not want, because really the degree of for instance, RAT that you want into this network may depend on your use case. And tying it hard-coded into the routing protocol locks it to a certain quality and locks it to a certain capability. Having it external, like RAT,
so I think you're absolutely right that there's a space of security of that, as you just described, with using remote attestation, with doing good enrollment before you hand out the layer 2 network key. That all makes a lot of sense to me, and it should be done anyway. But the stuff we never used that box is about signing DAOs such that in such a way that you know that this particular node can only announce address space that actually is below it or it's responsible for, right?
That was never proven. Actually, in 6LoWPAN, we have just produced RFC 89-2028, which provides a proof of ownership for the addresses that you expose over 6LoWPAN ND. And with unaware leaves, we are actually transporting that proof of ownership inside the DAOs. And now that can effectively be used to provide route ownership validation. But the existing DAO would not do that, because you could always write anything into your DAO. You prove that you're sending it, but you've never proven that what you're sending is correct. It needs to go all the way back to the source.
Yeah, you need to use a secure DAO, and most of the secure, the hex 8 something versions of those things, they didn't really get it right, and that was part of the debate back in 2012 or something like this. And so I'm not, all I'm saying is no, and no one's implemented it, right? So I think we could do a better job if we started over. The question is, what level of security do we want, right? So
yes, tying too much stuff which is not related to repo into this spec makes no sense to me. Better, deploy this spec plus this spec plus this spec, like RATs. If we need something special to prove ownership of the addresses that we expose, so we're sure that those guys are really down there, then that's when we can effectively modify repo and replace this section that we are taking off by a new RFC. I would not put it in 6550 bis because it would not be instant standard anymore. But I would probably try a new draft which explains how the rover can be challenged from a common parent up there. So when you see it coming from a new child, which means the guy is moved probably, you want to be able to challenge that the DAO was injected, from somebody who owns it, who owns the address. Well, there was a leaf down there which owns the address. So, but that's new work. That's not what that's not the property that this thing gives. This thing gives a property which is equivalent to the layer 2 security, kind of.
Right. So right now we're just relying on layer 2 security to make sure that no one injects incorrect, bogus routing information into our network, right? And so the point of the stuff that was there was to be able to validate those announcements at a higher level, irrespective of whether there's malware or something that rats would deal with on your network, right? So obviously if someone has the layer 2 key and has broken code, they're inside your network and they can do whatever they like. So that's an issue. But people at one point wanted to use Ripple in networks where not all the nodes were trusted the same way, or that the network was not encrypted, or the network was open in the sense of a open Wi-Fi kind of thing. And new nodes could attach and announce themselves, right? And that would work without them attacking other things.
So did we conclude about what we want to do? So like, do we want to do just this REPL v2 profile, or do we want to fix 6550 and then do the REPL v2 profile?
Ines says to bring it to mailing list. I would agree. I think that I think we need to figure out, essentially, in some sense, we need to figure out what our resources are. There are humans that are willing to do this. I think that while this is perhaps the smallest document, and probably one we can't really start until we can't really truly start until we've kind of gotten some of these other things, at least, to working group last call. Maybe not all of them, but I mean, at least some of them are in the queue already. But we need to figure out who's willing to do that, write that document, even if it's much simpler than the others, or if the other two possibly larger documents that may have to get written.
So Ines suggests to write and describe the various options and the pros and cons and discuss that on a mailing list. Is that something reasonable, or can we get rid of one of the options right now based on the discussion, so we have less editorial work to investigate or explain each of the options? Did I hear the first one, the big melting pot is out?
Maybe to ease the discussion, we could give names to things. For instance, for me, Abyss is not adding much stuff. It's mostly correcting to get to Internet Standard. So the Abyss would not be the melting pot. That would be the V2. The V2 can really bring new functionality. The Abyss is more like fixing bugs. If we agree on the terminology like this, it's kind of easier. Because we've seen many BIS in the past, and they were like that. I mean, 4861 is the BIS of 2461. Now we have 8200, which is the BIS of IPv6 2460, and many like that. They don't bring new stuff; they fix. On the other hand, OSPF v2 really brought new stuff versus OSPF v1. So I don't think we're talking about the same effort when we talk about the BIS and when we talk about the v2.
Okay, so let's talk about the V2, the big melting pot, the big one. Yeah. I heard Michael give an estimate for the resource that's needed to pull that kind of document. Do you think we have that? Do we have volunteers to do that, or can we just rule it out because nobody sees availabilities to do that?
At some point, we're going to need to do this, but it may be 6550 v2 BIS, but maybe not for a long time, and we may discover that if somebody has a interest in a resource and time that is not at this meeting right now. And some strategic next generation internet grant or something like that could fund such a thing, and someone could do some interesting work that way. But I would agree that it's probably unlikely that we'll manage to do this. So
okay, and it turns out we have people that are not in this meeting that are very active in the group, so I think it's about time to volunteer them, right? Okay, just kidding. Oh, too bad. Yeah, it's recorded.
I would be interested in making a pass on the original RFC 6550 XML to help contribute cleanup, because I was editor on the original spec, so I feel responsible for it.
Okay.
Actually, probably not a bad idea for us to obtain that XML from the RFC editor. It's available if you ask nicely, and throw it in, make sure that it compiles, and if nothing else, we may want to copy and paste from it for other things. So might as well have the original text and the original formatting.
Makes sense. And we discussed.
Pascal, did you want to share your screen? I saw a request, or was that a mistake?
No, I pressed the wrong button. I wanted to remove my camera. You eyes.
Okay. So we'll bring that to mainly describe the options and see who's willing and available for the various options. I think that's the best we can do at this point. Any more comments on this? If none, then we've reached the last item, which is open floor. Anything else you want to bring up?
Just a quick question about these beasts again. As I mentioned, normally it should be just 6550 without just fixing bugs. But for me, use of REPL info is really already a bug fix for 6550. So that's the one that I would like to see wrapping in. Does it make sense to people? Because it's very hard to do REPL without use of REPL info.
If we were to do you're talking about doing the going to internet standard thing. Yeah. So I would like to discuss how much, like, maybe we don't need the whole document when we go to internet standard. Maybe we only need the part maybe we don't need all 24 examples or any of them. Maybe we only need the beginning parts that clarify the text, because the document still exists as people can go back and look at it. So I don't know. I mean, I just don't want to start reformatting that document again.
No. It's just about stealing some text to make sure because RFC 6550 is not complete.
No, it's not complete.
Otherwise, we would not need use of REPL info.
Right. We absolutely, I agree with you. We absolutely would clarify those pieces. I'm just not sure that we have to clarify it with, all the pages that we had in that, right? Because we've already published it.
We can probably normatively reference, even if we are in the standard, can we normatively reference something which is not?
Down ref. Can we, Alvaro, in like that? I think so, but we may need a blessing.
Otherwise, we just steal the text we want and put the rest.
No, we should pull the text that's normative, that gives you the instructions of when and how to use it. But I'm just saying that we don't need to necessarily pull in all 24 examples, because we can certainly informatively reference that other document and say, if you need more detail, more details are in this document.
Yep.
Right.
Makes
okay.
Sense. But the
rule of how to write the code is clarified in the first 5 pages or something, right? And all the other pieces where it says updates, well, you just roll them in, right? That would make sense.
Yep. And then we would need to discuss if 23 is the only value known by the BS, or if we use the old value for the RPI.
Alvaro, you wanted to say something?
No, I was just too slow in trying to unmute to answer Michael's question, but he already answered himself, so I'm good.
Thanks.
I worked on RFC 8415, which is the roll up of DHCP v6 that obsoleted 7 documents over 10 years, all putting it into one document. And I just couldn't remember. No, it didn't result in an internet standard document. It still proposed standard. But I think there was discussion at some point that 2 years later it could be status changed up, but I don't remember that whether that was really the case or not. But anyway, the point is that's an example of I would say more of the melting pot activity, and that one certainly took 4 years to do. Probably could have been done in 3, but it took 4 years to do. Actually, maybe 5.
Okay, so I think we'll carry on with that discussion on the mailing list. Anything else? Any other points you want to bring? Hearing none, nothing in the chat. Last chance. Raoul didn't show up. I'm just looking at the list. Oh, Raoul just showed up. Rahul, we have a few minutes. If you want, we can put your slides up. I went through them very quickly, but you can probably go through the updates and stuff because I wasn't too sure, so I just skipped that.
Oh,
so why don't you?
Can you hear me, Peter? Sorry, Dominic.
Yes, we do.
I got the time zone incorrect. I thought it was 16:30 UTC. So if we have, how much time do we have?
You can have 10 minutes, 12 minutes.
Okay, all right.
And I went through the basics, the first few slides. So I don't know if you...
So these slides had been presented previously, a couple of IETF sessions before. The primary rationale is to provide an end-to-end way of making sure that the node's connectivity has been established to the root. Now, the mechanism that has been described in the draft is about setting a K flag in the transit information option on per target basis, such that root would know whom to send the root ACK back. So this particular slide talks about how the K flag is set, and on what basis the root can decide to send back the root ACK. Earlier we were calling it DAO ACK, but then there was a lot of confusion about the term used there. So in the later version, in the last version, in version 1, I changed it to calling it as root ACK. Next slide, please. So again, this is the K flag. One of the discussions that happened in the previous call was with regards to handling how would the 6LRs handle this K flag. In storing mode of operations, 6LRs could aggregate multiple DAOs together and send an aggregated target to the upstream nodes. If we have another flag, how would this be handled? The handling would be very similar to E flag. Currently, we have an E flag which specifies how to handle external targets. The draft has been updated to explain the different scenarios in which the K flag can be handled by intermediate 6LRs. Again, the handling is not very complicated. It's very similar to E flag. But then, what happens if somehow the K flag is still the intermediate node ends up sending a K flag because the path has changed? So all those things have been mentioned in the draft. In the worst case, an additional root ACK might be sent by the root with an old path sequence, but that's the worst case scenario. there was one more thing. So when this particular draft was supposed to be used for two purposes. One was a root node or any other node could basically send a root acknowledgement to the end node, to the target node, that would signal that the application traffic can now begin. The other option, the other use case was to query the capabilities of that node. But then in the latest draft, in the latest capability draft, we now have its own messaging. So this won't be needed there. So that particular use case is no more true for this draft now. Okay, next slide, please. So one more other clarification that was added. Pascal raised a point with regards to how to handle rules. There was a discussion on mailing list about how do you handle RPL unaware leaves and this acknowledgement. So this is something that has been clarified in the draft. Basically, one thing that has been mentioned in the draft is if a NS is sent by the rule, then the 6LR generates a DAO on basis of that on the basis of the rule, and immediately sends an NA. Now that NA can be sent in response to this root acknowledgement. What it achieves is that you can synchronously send only when the end-to-end path is established. The NA here can be synchronously sent. The C sends the NA only in response to the root acknowledgement. So only when the full path is established in the network, the NA gets sent back to the root. Yeah, next slide, please. So that's all. Those are the major updates. There have been major updates in version 1. There has been implications for delayed DAO being added in the draft as well. It just mentioned that what are the delayed DAOs and how do you handle delayed DAO timer. There has been no reviews on the draft, but I'm hoping to get some from the working group, and we're checking whether the working group is interested in this work. And that's it. Thank you, everyone.
Sure. Raul, actually, before you jump, we had a question by Alvaro on that, and we're a bit short answering it. Why don't we just cascade the DAOs up and the DAO back all the way to a root? This was discussed a few years ago, and it was found that this doesn't work. But since it's probably fresher in your mind than in ours, can you go through that again?
Yeah. So there are several approaches to ensuring this end-to-end DAO ACK works. So in the RPL observations draft, we had talked about what are the downsides of doing this. For example, one of the points that usually gets raised is if D sends a DAO, B sends a DAO ACK back only when it receives DAO ACK back from A. This has certain state implications. Again, if in the RPL observations draft, we have given a detailed problem statement about what are the problems with this particular approach. Maybe I should replicate those observations even in this particular draft as to what are the implications on state handling, why it becomes complicated, all these things. Again, those observations I had presented in several sessions. In several IETF sessions before, in context to RPL observations, draft. So one of the primary reason is the state handling that is required on the intermediate 6LRs to keep that DAO ACK, and that's one of the major problem. What happens if again, there are 2 or 3 reasons, different reasons which are quoted in the RPL observations draft.
Okay, fair enough. I had an observation reading your draft since we have a few minutes. The requirements section says you want to be able to handle DAOs with prefixes, target options with prefixes, which are not full addresses. But then that's section 3, and later down the document you say that the root ACK will be sent to the address extracted from the target option. What about if that was a prefix, not a full address?
Yeah. So for the prefixes, what we are saying is that if a node, we are taking an approach where even if the 6LR is advertising a prefix, it should still send the full IP address of its interface, including the prefix. We take the same approach which is taken for sending in the DIO when we send the target. There was one more. So you can send a prefix target, but still send all the 128 bits. This I need to clarify in the draft. There was one option that was described to handle this particular scenario, but I guess I haven't still made changes in the draft I haven't made any changes, detailed changes in the draft to explain this scenario. But there is a way to handle the prefixes as well. I guess I'll have to add this in more detail.
Okay, I'll write it in the mailing list anyway.
Yeah.
At some point, you asked to put the full address of the node in the DIO, even, and that's done actually. We've done that. I think it's the unaware leaf draft that we made this change. That's why we update 6550. But the change is we put the full address and we have a flag. And so I guess that when you want to send the root ACK, you send it to the full address. So it's a prefix. You have a prefix length, which is not 128, which is shorter, but still you put 128 bits because you have the full address of the node. That's already done like that in mobile IP, so it's just like using the same technique.
I just need to put in that explanation in this draft as well. That's true. That's precisely what needs to be. That's still not handled in the draft, though. That is something I need to change. That's true. Thank you, Pastor.
Okay. Do we have any more questions for Raoul? Okay, hearing none. It's 57, so I think we're right on time. Thank you for joining, and have a good day, a good night, and see you soon on the mailing list or at the next interim.
Dominique, thanks so much. Thank you, Alvaro, again and again for your reviews.
Thank you guys. Bye.